Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand the concept of generative AI. Generative AI refers to a class of machine learning models designed to generate new data that is similar to, but not exactly the same as the data it was trained on. These models are trained on a dataset and can then generate novel examples based on the patterns they have learned. A general adversarial network is a class of machine learning models introduced by Ian Goodfellow and his colleagues in 2014. GANs are designed to generate new data that is similar to a given dataset. The key idea behind GANs is to train two neural networks, a generator and a discriminator, in a competitive setting. Let's try to understand this. The generator is a neural network that takes random noise. This is a random noise. This random noise can be in the form of text, image, audio, or video. So it takes random noise as input and generates synthetic data, this one, as output. It starts with the random noise and gradually learns to map this noise to the data distribution it is trained on. The goal of the generator is to create data, this one, that is indistinguishable from the real data. Layman example of the generator. Imagine a forger who is trying to create a realistic looking paintings. At the beginning, the forger does not know what a real painting looks like. So they start by randomly splashing paint on a canvas. This is like the initial random noise given to the generator. Let's understand this. So, a fake painting is created. Now, what is the role of the discriminator, which is here? The discriminator is another neural network here that acts as a binary classifier. It takes both real data from the training set, that is from here, and the generated data from the generator as input and classifies them, that is it a real or a fake. The goal of the discriminator is to correctly distinguish between real and the generated data. So the binary classification is done. Is it real or is it fake? Layman example of the discriminator. The forger creates a painting and shows it to the detective. The detective then tries to guess if it's real or fake. The forger uses the detective's feedback to improve and create more realistic paintings. The detective also learns from this process and becomes better at distinguishing real from fake. Let's understand this. So this is the fake painting. Discriminator model is trained by the real paintings, and then the binary classification is done to classify that is the painting real or fake. The generator and the discriminator are trained simultaneously through a minimax game. The objective is to minimize the generator's ability to produce fake data that the discriminator can distinguish, and at the same time maximize the discriminator's ability to correctly classify real and generated data. Initially, the generator produces random data that is far from resembling the real data. The discriminator is trained on a combination of the real and fake data, improving its ability to distinguish between them. The generator is then trained to produce data that is more realistic to deceive the discriminator. This process continues iteratively, with the generator and discriminator playing a cat and mouse game, each trying to outperform the other. Ideally, the generator becomes skilled at creating the realistic data, and the discriminator becomes challenged to differentiate between real and generated samples. It's a continuous loop. This continues in a loop, the forger trying to make the paintings that fool the detective, and the detective getting better at catching the fake painting. It's like a game where the forger and the detective are in constant competition. Over the time, the forger becomes really skilled at making paintings that the detective cannot easily distinguish from the real ones. The detective, on the other hand, becomes so good that it's almost like a flipping a coin to determine if a painting is a real or a fake. At the end of this process, you have a forger who can generate paintings that look incredibly real, and a detective who struggles to tell whether a painting is genuine or forged. In the context of GAN, the forger is a generator network, the detective is a discriminator network, and the paintings are the generated data. The constant competition and the improvement result in a generator can produce the data that is very similar to the real data it was trained on. So this was all about generative AI. For more videos on generative AI, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos. Link given in the description box.